So in example number 5, we're going to use, we need to find A and B in this right triangle. And all we're given is just the angle 22 right here. So since it's a right triangle, we can use our trig ratios to find the different parts of it. So what I can do is I can say, first of all, I can do sine. I can use my sine of 22 degrees because remember, we got to write this out first. Sine is equal to opposite over hypotenuse. So I know I have 22 degrees, so I can find the sine ratio, decimal equivalent of that. I don't know what B is, the opposite side, but I do know what the hypotenuse is. So I'm going to say sine of 22 degrees is equal to B over 30. So first thing I'm going to do is find my sine of 22. So I'm going to put 22 and hit sine on my calculator. And I get 0.3746. And remember, I always go out to 4 decimal places. Now it just tells us to go, they want the answer to the hundredth. So if we got 4 decimal places, we'll well past 100th, so we'll get an accurate reading here. So I have B over 30. So now to solve for B, I have to multiply by 30 on both sides. And so my 30 will cancel out, and I will get, I take that number, which this 0.3746, I still have sitting in my calculator, so I'm going to just hit multiply 30, and that gives me 11.238. Now they want it to the hundredths place, so that 3 is going to round up to a 4 is equal to B. So 11.24. Now with this, if I wanted to find A, I could use the Pythagorean theorem to solve for A. Or the other thing I could do is I could use my tangent ratio to solve for A, because tangent is equal to opposite over adjacent. Or I can use my cosine of A, because my cosine is equal to my adjacent over my hypotenuse. So what I'm going to do here is I'm just going to do this real quick. I'm going to show you all 3 ways: the Pythagorean theorem, the tangent ratio, and the cosine ratio, and we should get all the same number. So then if I say my cosine, so I'll use my cosine first. So my cosine of 22 degrees is equal to my adjacent, which is A, over my hypotenuse, which is 30. So now I can say 22 degrees cosine, that gives me 0.92718. So that's going to be a 2 there. And that is A over 30. I'm going to multiply both sides by 30. And when I do that, I just cleared my calculator out. I'm going to go ahead and hit cosine 22 again. And so I'm just going to multiply that by 30. And when I do that, I get 27.815. So that's going to be 27.82 is equal to A. So the other way that I said I could do this was by using tangent. So I can say tangent of 22 is equal to opposite, which is 11.24, over adjacent, which is my A. So in order to do this, I'm going to go ahead and take tangent of 22. Well, in order to do this, I can't have A on the bottom down here. So I'm going to have to multiply this side by A, and I'm going to have to multiply this side by A. So then that will give me A times my tangent of 22. So I'm going to go ahead and find what that equivalent is right now. That's 0.404026. But I'm going to leave it as that, is equal to 11.24. Now to get rid of the A, or to get rid of that 0.4040, I have to divide both sides by that to isolate my A. So now I can say 11.24 divided by 0.4040 0.40. And that gives me A is equal to 27.821, which is just 27.82. So you can see that whether I use tangent or whether I use my cosine, I still got 27.82. And even if I use my Pythagorean theorem, which is, let's flip to a different color here, a squared plus b squared is equal to c squared. I know that I don't know what a is, so that's a squared, plus b squared is 11.24 squared is equal to c squared is 30 squared. So then a squared is equal to, let's see, 11.24 squared. That is what I put a equal sign. That's a plus sign. That is 126.34 is equal to 30 squared is 900. So then a squared, I'm going to subtract 126 from both sides. So 900 minus 126.34 gives me 773.66. I have to take the square root of both sides. So a is equal to the square root of 773.66, which gives me 27.8. And here I get 1/4. Okay. So if you look, I'm only off by a hundredths place. And the reason why, I'll tell you the reason why, is because right here, I only had it out to the hundredths place. If I would have had that out to one more decimal place, I would have gotten a more accurate answer because that puts air into there. But anyways, you can still see that no matter which way I do this, I get the same answer, whether I use cosine, tangent, or if I use the Pythagorean theorem.